Thank you. Good morning, everybody. I would like to start with a question. May I ask you, is there anybody in the room who's not familiar with the term MVNO, or at least doesn't exactly know what it technically means? Anybody? No hands raised. Okay, so the interesting thing is, if you would have asked this question in the middle of 2011 to the guys and girls working at sipgate, most of them, even the tech people, would have raised their hands because none of us know anything about that stuff at all. And only 2 years later, we had several thousand customers which relied on our mobile network. And this talk is about telling you the journey we made in those 2 years and the years afterwards, and especially from my, as a technician, point of view. And I'll start with a few words about myself. My name is Geisen. I joined sipgate in summer 2012, a short while after the actual development for our mobile network had started. Previously, I had developed and implemented mathematical algorithms for computer chip design, which is very far away from all this telecommunications and even network protocol stuff. But in the first few months I was working at sipgate, my team and I built one of the central components of our mobile network, and this was how I got into the field. And until today, this is still one of my favorite fields of activity at sipgate, this improvement and operating of our mobile network. And I think one reason for this is that it's just a pretty cool experience to have built some everyday infrastructure like a mobile network. So several of my family members now use sipgate as their mobile operator and rely on the stuff that my colleagues and I built over the years. And that's just really great. So to give you an overview of my talk, I will start with some words about sipgate in 2011. Why did we want to become a mobile operator? Then I tried to give you a sketch of the technical goal, what we had to achieve, tell you a little bit how we did the first steps into this field. Then I will talk about the implementation, how we did this MVNO stuff, and in the end I will share some real-life stories and things nobody told us before. Okay, so sipgate in 2011. Although the company was founded in 1998 and had already launched several web-based services, we started using the name sipgate in 2004, and we've been a voice-over IP provider since then. And the first product in 2004 was a voice-over IP service for residential customers in Germany, with the one key feature that we could offer regular German landline numbers. And then 2009, a cloud-based PBX followed. It's called sipgate Team, and although this was very successful and is very successful until today, there was one major problem, and that was that it took us several years to develop this before we did the first real release and got the first customer feedback. And after this, sipgate wasn't willing to take that risk anymore of such long development periods. And so over the years, we became a more and more agile and lean company. And this lean and agile approach is one of the main characteristics also for our mobile network development. And to give you a rough overview of the size, we were 75 employees, half of them being tech people, so developers, administrators, and telephony specialists in that time. I think this picture is from that time and showing at least almost all of the sipgate stuff. And then I want to set the technical stage. Asterisk and Caller have been central parts of our infrastructure since 2004, since we started this whole thing. And in the beginning of 2011, we started self-operating our SS7 interconnects, and we used the open source project Yate as SS7 soft switch. And we did this all of those years, but we started in the beginning of 2011. After several years of doing mainly Perl development, we had switched to Java EE in 2010 and have been using this since then. And so this was also one of the building blocks for our mobile network. And to make this again absolutely clear, no one at sipgate had ever built or run a mobile network. And I think even though we learned how to do this over the years and to operate our own network, and I think we are pretty good at operating our own network today. I think none of us would call himself a general mobile network expert. We just know the stuff we need to know for our own network, but if you have some general questions on mobile networks, there's probably much better experts in this room right now, which you could ask. Okay, so why did we want to become a mobile operator? Many customers demanded some kind of mobile integration for their PBX. And maybe you could say, yeah, everybody has a smartphone, just put a soft phone on there, and then you could use your VoIP-based PBX everywhere. This just was not an option. The Wi-Fi and the mobile data connectivity wasn't good enough at that time. And there were many workarounds in the field, many PBX providers offering, for example, smartphone apps from which you could initiate a call, and then it would look like it was initiated from your PBX or something like this. But that was not quite our vision. Our vision was we wanted to offer all telephony services a customer might need, but with two key features, and those were quite important for us. We want full-featured mobile PBX extensions, so you should be able to just use them as your usual PBX extension. So maybe picking up calls, transferring calls, calling your colleagues on their direct dials as you're used to. This is the one key feature. And the other one was that we wanted to break the paradigm, one SIM card, one phone number. And we wanted to be able, that our customers could be able to freely change and route each and every phone number they wanted, or as many phone numbers as they wanted, to their mobile phones. And I will come back to those two key features later on. So for us, it was quite clear we needed our own SIM cards. And fortunately, as almost all of you might already know, it's not necessary to build a whole radio network in a whole country to achieve this and to get your own SIM cards. And instead, the standards allow for mobile virtual network operators, where you use the radio network of a mobile network operator and do the central stuff yourself. And there are several levels of operation from MVNOs. For example, on the one end of the spectrum, you have slim MVNOs, which do mainly marketing and sales and leave all the technical stuff to the MNO. And on the other end of the spectrum, you have the full MVNOs, which do everything themselves. And as you might guess, it wasn't that easy for us as a still very small provider to get in touch with the big MNOs and to talk about becoming an MVNO. But in 2011, we finally found E+ as a cooperation partner to do this. And E+ was later on bought up by Telefonica Germany, so sometime I may talk about E+ and another time about Telefonica, and just because of this. And within the Telefonica network, we became, I would say, an almost full MVNO. We do most of the stuff ourselves. There are some exceptions. For example, they do the international announcement of all our identifiers for us, and we don't have any roaming agreements, for example, and we use their roaming agreements to make our customers roam worldwide. Okay, next up, the technical goal. What does an MVNO actually do, or a full MVNO, as I should say? And to explain this, I will need to talk a little bit about the whole architecture of a mobile network, so we can then see how this works together. And I will only talk about 2G in this case. It's called GSM. Then, of course, we also did 3G, UMTS, and much later on, we also did 4G. But for this explanation, I will just stick to 2G, because 2G and 3G are quite similar, at least from an MVNO's perspective. And of course, I just simplify a lot of the stuff, so to only give you a rough overview. We start with the so-called mobile station. It's the part you're maybe most familiar with. It's a SIM card together with a baseband chip and a mobile phone. And you could say it's the only real mobile part in the whole mobile network. And they acquire radio links with base transceiver stations, which is essentially antennas together with a little bit of control electronics, and they are controlled by base station controllers who take care of the signal strength management and shifting customers around due to overload and that stuff. and those together are called the base station subsystem, and all the radio-related stuff is mainly contained in there. So the rest of the network doesn't have anything to do with the frequencies and the signals and all of this. And then we have the network switch subsystem, which you might want to call the backbone of the network. And there's one central component, it's the mobile switching center, which comes together with a visitor location register, a database of the customers currently registered at that mobile switching center. And the mobile switching center takes care of location management, authentication, and it also makes the connection to the public switch telephony network for the calls. And then you have one central component. This is the home location register, which is essentially one large database where you have all the information about the identities of the SIM cards. You have the crypto keys, and it comes together with an authentication center, which generates the crypto keys you need for the secure radio links over there. And there's another central component, the short message service center, which does essentially what it says on the tin. It transmits short messages to other customers or to other networks. And what's missing in this picture right now is mobile internet, and in 2G it's called GPRS. So we have down there the serving GPRS support nodes, which kind of corresponds to the mobile switching centers. They're also taking care of location management, also talk to the HLR to do so. And then they, for the actual data sessions of the customers, they open up a tunnel to the gateway GPRS support node down there, which then makes the connection to the actual internet. Okay, so this is a rough idea of a mobile network. Where does the MVNO come into place? The first thing we would have to do is to buy or build or otherwise achieve HLR and SMSC, and to offer those interfaces for the SGSN and the MSC. Second part, allow some kind of connection to the telephony network and to the internet. And the last part would be produce our own SIM cards, tell those SIM cards to what network they should connect, and ship them to our customers. So this is what we had to achieve. How do we get started? There was one central decision, and that was that we didn't want to buy any black boxes. As as you might have seen when you watched James' talk yesterday, those are pretty expensive, and you have essentially no possibility to modify them or extend them for your own needs. And so we wanted just to prefer open source software, self-written software, or at least licensed software that we could extend for where it's not otherwise possible. Okay, so self-written software, open source software, that sounded like we had to learn a lot of stuff. And in order to learn this, we contacted the Osmocom project, which is a very cool open source project, which has many, many sub-projects, and they have the software stack for almost every component in a mobile network you would like to have. And they also have some very nice software tools and hardware tools for debugging SIM cards and working with SIM cards. And we also got one of their founders to work with us as a consultant for designing our infrastructure and teaching us everything we need. So this worked really well for us. And then, yeah, we had to read a lot of specifications. We had to read all the standard specifications and the specification from our MNO. And as you might already have guessed, we had to learn an awful lot of abbreviations. Then we needed some kind of laboratory setup, right? We needed some SIM cards to play around with and all this radio equipment in our office so we can then start the developing of our components. And there were first some physical things we needed. We needed to apply for some test radio frequencies to be able to operate this in our office. Then we bought up some radio equipment. This is a small GSM cell over there we bought. And we also needed some writable SIM cards. Okay, now when we look again at this big picture, what we wanted to build was those colored components. But what we needed first were those white components on the top, at least those to be able to implement against them and to get all the stuff up and running. And how did we do that? We ran the radio cell, which came with a soft BTS, you just saw in the picture. Then we installed OpenBSC, which is the BSC component of the Osmocom project. I think today it's called OsmoBSC, but back then it was OpenBSC. And unfortunately, there was no Osmo MSC back then, and so we had to license a proprietary software MSC, which came together with a VLR. And unfortunately, those two components weren't able to talk to each other, so we had also to buy some translation equipment to get this working, and then we had to configure this whole stuff. And as you might see, it's very patchworky, and it was quite a nightmare. I think they started several weeks before I came into the company, and when I joined the company, it was still a nightmare. And but in the end, we got it working, and we figured out how to do this. And so we had a small 2G network in our office, and we could really start working with this. Okay, now to the real magic, our MVNO components, how we used them in production, and how we basically implemented them back then. I will start with the part we were a little bit familiar with, the part between the mobile switching center and the telephony network. And as I said, we already had SS7 interconnects, and this one wasn't very different. So we used Yate as an SS7 soft switch, as I said before, and we routed the calls to our Asterisk gateways, which are kind of an entry point for the calls into our normal network. And this is where we can implement one of those two key features I mentioned earlier, this full mobile PBX extension, because once a call is in that network, we have every feature we implemented for our VoIP customers. We have normal billing, normal PBX features, all of this. And there was one small exception which we had to build in addition, and this was that if you have a mobile network and you have a call terminated to a customer, you just can't terminate that call to the registered extension as we did before, but instead, at first you would have to ask the HLR, where is this customer currently located at, so you could then terminate the call to the right MSC. And so we built some interface, so the Asterisk can first ask the HLR, where is this customer located at, and then terminate the call to the right MSC in the field. And in addition to this call-related signaling, we had a lot, there is a lot GSM-related signaling, like location management and authentication and all of this. And this was all totally new to us. And this is what I come to next. And we routed all this GSM-related signaling through the same Yate instance I just showed you farther on to a component called signaling endpoint. And usually a signaling endpoint is only dispatching the messages to the attached applications, for example, like a home location register. But in our case, as we also use Yate for this, this comes with a special module which takes care of the transactional and the connection layers of the protocol stack, which is quite nice because then we can just focus on the GSM payload of this protocol. And then we built one Java EE application server and to take care of the HLR, SMSC, and authentication center stuff. And as I like to say, this is where the magic happens. This is what we built ourselves. This is where my team and I came into play. We built the SMSC back then. Another team essentially built the HLR. And because we did this ourselves, we could really, really well integrate it into our backend. And to only give you one of many examples, this one SIM card, one phone number paradigm that we wanted to break, this is essentially possible because we just do some mapping. We store the routing and the phone numbers of the customers in the database, and then we have a mapping to the SIM card, and we can just change it however the customer wants. So for example, if a customer has a broken SIM card, he just can throw it away and get a new one, activate this, and all his routing just stays into place. So it's just only a piece of plastic anymore. And the last of the big components, the GSM to the internet connection down there. We had to achieve two things for this. First, we had to offer a radio server, so the GSM could ask for allowing or denying customers to use the data session. And the second thing was, and we used free radios for this, obviously. And the other thing was that we got a plain IP line and for the actual traffic of the customers. And we needed to do some nutting and routing and throttling of this traffic, but we did all of this with plain Linux tools. So this is just a plain Linux machine and routing all the stuff. And to control those two things and make the connection to the HLR, ask the billing service whether the customer is allowed to use this or not, we implemented one control service in the middle, which is again a Java EE application server to keep track of all this stuff. Okay, so this was the dry technical stuff, I think, how we thought this might work and how we implemented it, and yes, we did that, but it's only the first half of the story, I think. After we started having real users in the network, there were many, many surprises for us, many things we had to learn on the way, and yeah, it was quite a long way, but also, I think, quite interesting. We started in August 2012. We had the very first version of our HLR running, and we wanted to get real user feedback as early as possible. There was no data support, there was no short message support, there was no roaming, but you could register a SIM card, get a call, make a call. That was running. And we started by doing some internal alpha tests. And this was really great because 20 of our colleagues had exchanged their real normal SIM cards by those prototype SIM cards. And I was one of them. I was only in the company for 3 or 4 months at that time. And that was really excited. They trusted me to do this and to get this card and to give them feedback. And that was really, really, really good. And you can see this is a really picture from back then where we already had those nice paper containers for the SIM cards ready, but we still were working with the prototype SIM cards because we weren't just sure if they would even work in production. And along the next months, we figured out many, many bugs. Thankfully, Wireshark has GSM support, so we did a lot of tracing and analyzing in that time. And there were many obstacles we just hadn't seen coming. So for example, we only had landline numbers in that time, just because our mobile phone numbers weren't ready yet, and some colleagues wanted to use WhatsApp once we had the data support in there, and but WhatsApp just wasn't able to take a German landline number as your cell phone number back then. And so we had to contact them and say, yeah, it's a real scenario, they're real users, they only have this landline number on their SIM cards, and please make this work. And they made this work, and today you can use WhatsApp with a German landline number. And although today, of course, we also have mobile phone numbers, this was just one of many, many cases. In the first half year after the launch, in summer 2013, we had mainly focused on implementing missing features. So for example, we had just finished the SMSC as we wanted to implement it, and this whole setup was more or less in a prototype stage. It was redundant and it was well monitored because we did have customers on this, but it wasn't prepared for many, many customers. And this caught up with us on one Friday evening during an office party, of course, where the system just crashed suddenly. And luckily, we had no clue what it was. We just didn't know anything. Luckily, it recovered on the same evening after we had just poked in somewhere and just tried to work out what was happening, but it recovered. And after this, we came into the discussion, what should we do about improving the performance and the scalability of the system? And we figured out some plans. And during these discussions, this next Friday came, and with the next Friday came the next crash. Well, then we stopped the scheduled work of 2 of our teams, and we worked really hard in this week to implement the first improvements. The first performance improvements was, I think we did not manage to do enough of this in the first week, and we had the 3rd Friday, the 3rd crash. That was really hard for us. But in the next week, I think we finished to refactor enough of the crucial processes, the crucial components, that finally, the 4th Friday, we had no crash anymore. And yes, that was a really hard time, I think, but yeah, of course, we also learned a lot. SMS. SMS is surprisingly one of the biggest pains we had in the last years with our mobile network, and it is still today. And you might think, but why? SMS, isn't it just that? So, and we also thought so in 2011. We weren't even sure if we should implement it at all. But then more and more services implemented two-factor authentication over the years. And those two-factor authentications, in many, many cases, rely, at least at the end, on sending short messages. And those short messages reach our network via international traffic usually, and to get all the services and all the providers out there to send their messages to our customers is surprisingly tricky. And in the beginning, when we got customer complaints that they weren't able to receive SMS from Google or Twitter or what else, we digged into this. We technicians digged into this and did some debugging and tracing and analyzing. And in almost every case, we had to learn that it was not a technical problem. It was more a problem of having the right agreements with the right other providers, with the right international hubs, and all of this. And so this is the point where this guy comes into play. This is Percy, a colleague of ours, and he's not a technical guy. He's the one that does all these agreements with the other carriers. And in the beginning, we had to provide him with debugging information for every case. But then at one point we just stopped doing this and instead gave him the opportunities to look in the logs himself and do some analyzing, providing him with some data. And I think today he's even able to connect a new provider to our SMSC without having us involved anymore. It just has an interface to do this, and so we can focus on stuff where we can really make a difference, and he can work on his own and have this all running. Yeah, but still today, this is an ongoing task for us. Eat your own dog food, or as in using your own services that you offer your customers for your day-to-day business and everyday life. And we like to do this usually, and we also did so with our SIM cards. We exchanged, or many employees at sipgate exchanged their normal SIM cards with sipgate SIM cards to just be closer to the customer's experience. And this worked very well for us. The only thing that we didn't exchange, we exchanged, I think, all of the SIM cards but 3. And those 3 SIM cards are the SIM cards for the on-call phones, because it doesn't really make any sense to monitor a mobile network and then get the notifications to SIM cards within that network. So those are still from other carriers, but all the others were switched. In 2014, at the end, at the 31st C3, the annual Chaos Communication Congress of the German Chaos Computer Club, there were several independent work groups publishing heavy SS7 security problems. And this caused a lot of buzz, even in the mainstream media, at least in Germany, and all the big MNOs had to do a lot about this, and to put up some firewalls, and all of this. And we also used this opportunity to get an external audit on these topics for our network. And I think I might not share each and every reason why this went out quite well for us, but I only give you my favorite one, and this is that there were many features exploited in these reports that we hadn't implemented at all, because they have never been valuable, neither to us nor to our customers, and I definitely call this an agile for the win. Another thing we had to learn was related to data roaming. And the way data roaming works is a customer in a foreign country tries to use this data session, we get a request, we can say access or deny, then we bill the customer for the traffic, and later on we get a bill from the roaming carrier over this traffic. And back then, our agreements only allowed for offering data roaming within the EU for reasonable prices. And what we missed out when we implemented this EU check for the customers was that there are those satellite-based radio cells on the cruise ships that do have an identifier that tells you, I am a satellite cell, but they are operated within just normal carriers' networks. And then we implemented the check, and we got a request from a customer, maybe in the Mediterranean Sea, and we got that, and it was, oh yes, this is an Italian VLR, we can just allow this. And the customer was probably very happy to use the data traffic on the ship, and but that resulted in very, very, very expensive bills in the middle of the first summer after launch. And yeah, since then we also check for the cell ID before we allow such a customer to use the data session. Then we did some improvements of our development environment. I told you about this GSM playground, this laboratory setup we did in the beginning, and it was very important for us to have this back then. But over the years, it wasn't necessary to do anything with the mobile network so often, and every now and then when one had to work with it, or debugging something, whatever, it was, again, just a bigger nightmare. Because nobody knew this very well, you had to do some widely reboots of all these patchworky components, and in the end, you almost always had to find that one guy that knows the special voodoo trick how to make this again work. And so after several years of a stable production environment, we decided we just throw this away, and instead some of our colleagues, I think Göran was part of them, they took several hundred SIM cards and they marked them with this green line and put them in a cupboard in the office, and they built a bypass from the production environment for this specific SIM cards, and now we can just use those SIM cards in our development environment as if they were development SIM cards, and this worked quite well for us because now almost everybody at sipgate can just use SIM cards in the development environment without having to know all this other stuff. And I think this is the last story I want to share. It's about SIM cards. Of course, we had to learn a lot about SIM cards. There are many, many manufacturers out there. We contacted many of them. We tested a few. I can tell you one thing. No one of them is prepared for working with such rookies that we were. All of them are only prepared to work with companies that are in the field for years and know all this stuff, and the documentation is really, it's not suitable for newbies in the field. So that was not that easy, but we managed to learn that, and once in a while we had to order more SIM cards, and we had one colleague who did this, and when last year came and we needed more SIM cards again, this colleague had left the company over the year, since the last order, and so we had a team sitting there with the scripts that were supposed to generate the necessary data for the new SIM cards, and it wasn't that easy to figure out how it should really work, but in the end they managed, and they used the scripts to generate the data for the next 50,000 SIM cards, and they encrypted it and sent it to the manufacturer, and a few weeks later, this handy package arrived at sipgate with those 50,000 SIM cards. And then, yeah, everyone was happy. We put one of the SIM cards out there, put it into a mobile phone, and it didn't work. It wouldn't want to register, neither at the first try, nor after some debugging. It was just a nightmare again. And they tried a lot of stuff. They contacted the manufacturer, and there was quite a while where we all thought that it was just not possible to make this 200 kilograms of apparently plastic scrap work for us. I mean, I think this package is about 80,000 euros for those 50,000 SIM cards, which is just very heavy and expensive plastic scrap if you can't make it work. But in the end, after several contacts with the SIM card manufacturer, we finally figured out that they had decrypted the data we sent them with another key than the one we had encrypted it with. And luckily, we were in the possession of both keys, and there was no security problem with one of the keys. And so we got all the data from our database and did some decrypting, encrypting, recalculation, and all those stuff. We put it back in the database again, and now all these 50,000 SIM cards are working. And yeah, with this relief, I will come to the end of my talk. I hope I could share that we definitely encountered some massive obstacles. And we also definitely made some very stupid mistakes along the way, but we also learned an awful lot of amazing stuff. And we had incredibly much fun doing this. I mean, learning all of this, making it work, seeing the customers using it was just great. And so I think the most important thing at this talk is we did it. And with this, I will thank you for listening.
Fantastic, fantastic. Great story, and we learned lots of acronyms, which is the most important thing. So,
you're showing earlier on when the MSC, with you hooked out the calls to send to your PBX. You were doing it on the mobile extension. How were you doing that with the call routing? So if any dial, were you using like IN triggers or something as well to actually get the call? So when the call hits the MSC from the subscriber, it's the MNO's MSC, yeah?
Yeah.
So I dial 1234.
Yeah.
That's going to hit their digit analysis, or how did you get the calls into your network rather than just like
when they do the direct dial calls? Or
yeah, well, yeah, when they do like the
essentially, we
1234.
get all of the calls from our customers into our network.
Yeah. So how did you do that?
It's just part of our MVNO agreement that we just
So
when
they were
the
just
customer
routing everything to you.
I mean, in Germany, when the customers in Germany, the MSCs are all MSCs from our MNO, and it's just part of the agreement that we receive all the calls that are originated by the SIM cards. And for roaming cases, we implemented Camel.
Right, yeah, okay, so Camel
do
IN
this.
stuff.
Yeah.
So they probably had IN in the E+ network to do the same thing, effectively, to get the calls to you.
No, I think they just configured the MSCs to, at least that's what I know.
But yeah, you had Camel for the roaming stuff.
Yeah, we have Camel for the roaming stuff, exactly.
awesome. Okay, David over here had his hand up next, so I'm going to give it to him.
So what was happening on Friday night that the system started to crash every Friday night? I mean, was it specific load that there were more users on Friday night that were using the system, or was it some kind of bug where at a specific time the system started to crash? Like what was happening then, and how did you figure that out? What was causing it?
I think it was a mixture of both having a load peak on that evening from our customers, and I think there was some flushing of components at the MNO side. So there were many reconnects to the network, and until then we hadn't done much effort into the scaling of the systems. And so what we did afterwards was just making more of those processes asynchronous and saving some resources and not waiting for the cells to answer, for example, and some usual performance stuff, I would say. But
So basically, a lot of background work was being done at a specific time, and that's what overloaded. So you weren't doing any. So what you're saying is you didn't do stress testing.
No, we didn't.
Okay.
We just grew with the customers. So in the beginning, we only had those 20 SIM cards, and we wanted to make them work in the first place. And then we got more and more customers, and we learned more and more about the scaling and the necessary performance improvements.
She got a PhD from the School of Hard Knocks.
Laura, thank you. So that's very interesting. I'm just curious, in 2019, in the LTE world, maybe it's too big a question, but I understand it's IP all the way and so on. Is it all different? What's still in common from that GSM architecture that's very much out of the circuit switch SS7 world?
Oh that is maybe a larger question. I can just maybe share some details about this. In the end, we did the very similar thing, but we had to do the same thing again. So we again use E8 for the diameter routing, and we built a Java-based HSS for doing the location stuff. And we try to be as much protocol agnostic within our network as possible. So we just made the connections from those new components to connect to the old network and have this LTE special stuff capsuled in there.
Okay, one last question, and then we're going to leave time for Boris, because he's next up.
Try to make it fast. Laura, thank you. Did you find at any point when you were booting up your services that the competition or the existing infrastructure was jealous enough to attempt certain things that weren't working? You know what I mean?
No.
Was there resistance to your coming online from the existing infrastructure people, which would have been what, Deutsche Telekom?
From the other carriers,
Yes.
you mean?
Well, other carriers or whoever was controlling everything that you were connecting to.
Yeah, I heard a lot of stories about having regulation problems. There was not that much of a problem for us. I think there is much regulation going on in Germany, but we were already used to. So we have guys at sipgate working on all those regulation things, and there wasn't much mobile-related special stuff back then. And yeah, once we were in the field, no, I don't think there was much resistance. It wasn't that easy to get some German mobile phone numbers. Maybe this was the trickiest part, but in the end it was all doable. So yeah.
Very good. Well, let's give Laura a real big round of applause. And we've got just a couple of minutes till Boris picks up the stage, and he's going to talk about Jitsi Video Bridge and go from there. So, all right, so let's do a quick change.